Welcome to the video notes for lesson 4-10. This lesson is about parallel and perpendicular lines. Our learning target for this lesson: I can determine whether lines are parallel or whether lines are perpendicular. And we're going to do that by taking a look at some things that we've been discovering and learning about in this unit when it comes to lines, primarily the slopes and the y-intercepts. I just want to talk about what parallel and perpendicular means. On your paper, by the way, this comes from page 39 in your notes packet. Above parallel, I want you to put, that's not 11. Think of it as an equal sign that is turned vertical instead of horizontal. Parallel lines are lines that never intersect. So this is the symbol for parallel. Like I said, it looks like an 11 or an equal sign that's turned vertical. So if you ever see that, it should make sense. I always remember it because the word parallel has two L's in it, so it looks like the symbol. Perpendicular, that symbol is this, an upside down T. Let me make that a little better. And sometimes you'll even see this in the T, and hopefully you'll understand what that means, that this is a right angle. So perpendicular lines are lines that intersect each other, and where they intersect is a right angle. So it's not just that they cross each other, but they cross each other in such a way that they create a right angle. Alright, so we have two examples on this page that we're going to talk about. It says, write the equation of the lines for each graph, compare the slopes. Not only are we going to compare the slopes, we're going to compare the y-intercepts, because that is important too. The equations we're going to write are in slope-intercept form, y equals mx plus b. We could use the other forms, but this is the most typical way that you will see it, so it makes the most sense to stick with that. Alright, so let me move the paper up, or scroll the screen up here. Alright, so we know we're going to do y equals mx plus b. Let me split my workspace in half here. So I'm going to draw a line down the middle, and I suggest you do the same, so that we don't get things crossed up. Now, just looking at the picture here, I can tell that these two lines are never going to intersect. So these are parallel lines. So we know we're dealing with parallel lines here. Alright, so I've got line 1 and line 2. And what I need is M and B to be able to write the equation for both of these. M and B. Alright, so for line 1, I look where it intersects the y-axis, and it's at the point 0, 4. So there's my B, it's 4. Then to get M, I do change in y over change in x. So what does it do? Well, it goes up 3. So the change in y is positive 3. And then it goes to the right 2. So the change in x is positive 2. So up 3 over 2. So my M is 3 over 2. So what is my equation? Y equals 3 over 2x plus 4. The second line, the y-intercept is down here at, it's kind of hard to see here, negative 3. So B is, so that's the point 0 comma negative 3, and the B value is negative 3. So now I need to find the change in y over the change in x. And when I do that, I go up, so I'm going to go from this point to this point. So it goes up 3, so change in y is plus 3, and to the right 2, plus 2, change in x is plus 2, so 3 over 2. So M is equal to 3 over 2. So what's my equation? Y equals 3 over 2x minus 3. Alright, so what do we see here? Here's one equation, here's the other equation. If I'm comparing the slopes, like it mentioned above, they're identical. But there's something else important to note. The y-intercepts are not the same. And the reason why that's important is, if they were the same, it would be the same line. So that's why the y-intercept has to be different. So parallel lines clearly have slopes that are the same or identical. Alright, so now let's take a look at the next example over here. And I'm not sure if you can tell just by looking at it, but I can. Of course, I know what it's going to turn out to be. These are perpendicular lines. So going into this, I know my lines are going to be perpendicular. And I can tell you right now, just by looking at it, this line is increasing as it's going left to right, so it's going to have a positive slope. This line is decreasing, so it's going to have a negative slope. So I'm not going to have the same situation that I had with parallel lines. So let's take a closer look by finding the equation. So m equals and b equals for line 1, line 2, same thing, m equals and b equals. Alright, so for line 1, that's this line here. It's going to have the negative slope. My y-intercept looks like it's right there at point 0, comma 6. So my b is 6. My change in y over change in x is, so I'm going to go from this point to here, and then I'll just confirm it by going to here. So I'm going down 2, so that's minus 2 for a change of y, to the right 3, so that's plus 3 for a change of x. Down 2, plus 3. So negative 2 over 3. So my slope, my m, is negative 2 over 3. My equation then is y equals negative 2 over 3x plus 6. So that's the first line. The second line, my y-intercept is here at 0, negative 2. So there's my b, negative 2. My change in y, my rise overrun, over change in x equals. So I'm going to go this way, and it looks like my next point is here. So I'm going up 3, right 2. So plus 3, plus 2. Just like over here, I have a positive 3 over a positive 2, or 3 over 2. So my equation for the other line, y equals 3 over 2x minus 2. So very different. Not only are the y-intercepts different, but the slopes are different. And they are different in a very specific way. And I'm going to talk about that on the next page. But this is what you have with parallel lines, same slope, perpendicular lines. There's something different about the slope, and we're going to talk about that next. So on page 40, we have some more examples here, and it's a very specific property here. I want you to read this to yourself, but about parallel lines and how they have the same slope but a different y-intercept. So, same slope, 2/3, different y-intercept, and that's why they are parallel. I actually did this one on my own. Actually, you know what? I can do this real quick. So, let's graph this super quick here. So, the first one, I'm going to graph. There's my y-intercept. It's positive 1. Tricky to find that on this grid. So, that's right there. And then my slope is up 2 over 3. So up 2 to the right 3. Up 2 to the right 3. Or we can go negative, negative. So down 2 to the left 3. Alright, I have enough points there that I can draw my line. So I'll do that, and it looks like this. Make sure you're using a ruler when you're drawing your line so it looks accurate. Okay, the other one starts at a y-intercept of -3, so go down 3 from the origin. And then same slope, up 2 over 3, up 2 over 3, or down 2 to the left 3. And you have the same situation where these are not going to intersect, they are parallel lines. Okay? So your reason for them being parallel lines is they have the same slope but different y-intercepts. Two over 3, but different y-intercepts. Okay, now the one below this talks about more specifically with the perpendicular line. So let's take a look at this. This we're going to read together. Two lines are perpendicular if the product of their slopes is -1. So remember, the slopes on the other side were, one of them was -2/3 and the other one was 3 over 2. If you plug that into your calculator and multiply it, so -2 times 3 is -6, over 3 times 2 is 6, -6 over 6 is -1. So if the product is -1, a vertical and horizontal line are also perpendicular, by the way. So another way to think of this is these are what I like to call negative or opposite reciprocals. Okay, so we have a couple more lines we're going to graph. I'm going to do this the quick way, so if you have a hard time keeping up, pause the video. I'm going to use the slope and the y-intercept and do the rise over the run. So the first one is a y-intercept of -1. So go to the origin, go down 1, put a dot. And the slope is -1/4. So I go down 1 to the right 4. Down 1 to the right 4. Or I go up 1 and to the left 4. Up 1 to the left 4. And then I connect my dots using a nice straight line, ruler. And this is why it's important when we're dealing with parallel and perpendicular lines that you use a ruler so you can really tell that it's true. So now my y-intercept is +2, and my slope is 4, which really means 4 over 1. So up 4, 1, 2, 3, 4, to the right 1. Up 4, to the right 1. Or down 4, 1, 2, 3, 4, to the left 1. And down 4, to the left 1. And connect them with a nice straight line. And you should be able to tell that right here we have a right angle. These are perpendicular lines. And you'll notice up here when it talks about this example that their product is -1. My explanation again is the slopes are opposite reciprocals and their product is -1. So let's write it down so we remember. The slopes, this is your explanation of why they are perpendicular. The slopes, so -1/4 and 4 over 1 are opposite or negative reciprocals and their product is -1. Alright, that's it. This is a pretty big idea. So if you had trouble with this, go back and rewatch the video. Or get help from a friend. Or come and see me. Good luck, and we'll see you in math.